If you ask a child how a machine like Alexa understands what you're saying, how a car that drives by itself can do what it does, or how autocorrect can predict what you'll say next, the usual response will be something along the lines of, "Oh, well, that's because Alexa has a microphone and a car has a camera and sensors so it can see and detect things, and autocorrect is constantly looking at what you type." But this is precisely why most people start off on the wrong foot when considering artificial intelligence, because the magic sauce of artificial intelligence is not in the input mechanisms, the camera, the microphone, the sensors, the detectors, but this is a totally natural first thought because these are the more physical, more tangible features of machinery. But the funny thing is that if you ask the same questions about humans, how can we understand what others are saying, how come we can drive through the crowded and reckless streets of New York, very rarely will the answers ever be, because we have ears and eyes. No, because having ears and eyes is not what separates us from the rest of the species on the planet. Rather, it's what goes on inside our brains. It's about how the information we've gathered is processed, not about the information itself which is gathered. This is precisely the first distinction that must be made if you want to understand artificial intelligence. The secret sauce of AI is all in the way that the computers are starting to think and make sense of its inputs. Before we go any further, I want to address some common AI jargon that's constantly thrown around, often carelessly. In short, the field of artificial intelligence deals with the ability of machines to do things that we, as humans, would consider smart. Machine learning is a subcategory of artificial intelligence, which we'll get into very soon. Artificial neural networks are one such state-of-the-art mathematical machine learning technique that's had a major spike in the recent years. And deep learning is when we take the math concept of a neural network and scale it up to undertake immensely complicated tasks. But machines have had the ability to quote-unquote think for centuries, so what's so different today? Well, the difference lies in how they're starting to think. Let's say we want to teach a computer how to recognize whether it's looking at a dog or a car in a picture. Well, you'll hopefully start off by saying something like, if you notice ears, meaning that if you notice these pixels form this particular shape, then that's a sign of a dog. If you notice wheels, meaning these bottom pixels here, forming circular shapes at these locations, then it's a car. Then you continue this way, writing rules for what's an eye, and what's a windshield, what's a nose, and what's a headlight, and maybe this will work for one dog, or this one car, and this one, but what about this dog? And what about this car? Or this one, or this one? Imagine all the rules that you'd have to write. It would be a complete mess. Also, what if you just rotated the images that appeared to initially work, or scaled them up or down, or twisted or turned, or made them a bit darker or lighter? You get the idea, it wouldn't work. Writing rules for this kind of a job is a disaster. This is exactly why jobs such as those of a radiologist or the TSA officers at airports, taxi drivers, or farmers were considered safe until today. So what changed? Well, pretty much somewhere along the line, we thought, what if we didn't have to write the rules for a computer? What if the computer wrote the rules by itself? No one makes a newborn baby sit down and listen to a lecture on how to walk, and you didn't learn, say, how to ride a bike or play Fortnite properly just by someone telling you how to. You figured out almost everything you know today by yourself, through experience, and that's something to be proud of. But this would not be possible without all the resources you had to experiment and fail multiple times out on your own to learn from your mistakes. So what if the same logic was applied to machines? What if instead of trying to tell machines the difference between a dog and a car, we taught the machines how to learn the differences on its own? So it could be like, this is a cat, and this is a car, and this is a cat, and this is a cat, and this is a car, and this is a car, millions and millions of times. Turns out that not only can the computer do this, in certain cases, such as in retinopathy, which is the examination of retinas of the human eye to detect disease, it can actually do better than professionals in the field. So why is this technique so powerful? Because the bounds for which how complicated the rules that it can come up with increase very rapidly with the number of things that you give it to play with. The most simplest example of this is linear regression, which is just fancy for finding a line that best fits a set of data points. But not everything in life happens in a linear fashion. I mean, obviously the rule for how a certain pixel's RGB value affects whether or not something is usually a dog or a car is not going to follow a linear map. So instead, we use something called a neural network, which is a completely different function. That's all it really is at its core. A giant non-linear function that attempts to fit itself to the data. So how do we train this guy? Well, first we just have to gather a lot of data, massive amounts of data, and in our case, this means getting lots and lots of pictures. We feed each of the images through the network and it makes a guess. We find out how much it was off by and fix the appropriate results. After doing this many times, the guesses will get better and better. If your data is good enough, it'll learn a unique pattern. For complex problems such as image classification, even extremely tiny bits and pieces of this magic pattern are extremely hard to describe in English. This leads us to the first issue in machine learning. If something like a self-driving car ever makes a mistake, how do we know why it did what it did? Like which weight or combination of weights were the reason for its decision? Secondly, if the car gets in an accident, who's even to blame? The programmer or the AI? Another major issue arises due to the high dependency of AI on collected data. The problem is that data comes from humans, and humans are very biased. Unfortunately, this means that whatever biases we have as humans get passed on to the machine. This is a huge problem. In this case, the bias that presented itself was due to the lack of a racially diverse representation in the data that was used to train the AI. And Microsoft once made an AI that scanned Twitter for 24 hours and used what it learned to post its own tweets, and just in this short interval of time, the innocent bot was completely ruined and started spewing out extremely offensive things. This is a huge problem, especially huge because these systems are starting to be used in the judiciary system as a means for predicting whether a convicted suspect will repeat crimes committed. And there's no easy fix for this either because some of our biases are super nuanced and it's really hard to detect them. Another issue with artificial intelligence is a far more commonly feared one. Will it take over the world? Well, so far, the type of artificial intelligence that we've dealt with is extremely limited. Even a superhuman image classifier is not going to just wake up one day and be like, I'm going to kill you. So why worry at all? As eminent cognitive psychologist Steven Pinker believes, AI is not nearly as big of a threat as it's often painted to be. Mark Zuckerberg, Sebastian Thrun, Andrew Ng, and Yann LeCun are all in agreement with this view. Pinker even criticized Elon Musk, a strong believer in the threat of AI, by saying, if Elon Musk was really serious about the AI threat, then he'd stop building those self-driving cars. Musk quickly fired back on Twitter, outlining the difference between the very specific intelligence such as those in self-driving cars and a more generalized intelligence such as that of humans. The reason that we're a form of generalized intelligence is because we can perform a wide variety of tasks and quickly adapt to learning new ones. The mathematical techniques learned thus far are not capable of such broad levels of thinking. One area of study in artificial intelligence seeks to find whether we can design any such master algorithm, combining together various different types of machine learning techniques. But so far such an algorithm has yet to be found. If such an intelligence system that surpassed human intelligence were designed, then what's stopping it from being considered conscious? If it is conscious, then what exactly is the physical thing that we're considering conscious? The computer or the algorithm? So if the algorithm were written down mathematically on a sheet of paper instead of being incorporated into a computer machine, and if instead of a computer running the algorithm, if a mathematician quote-unquote ran the algorithm on a whiteboard, can that still be considered consciousness? Well, if it is conscious, then does it have rights? And can it be held accountable for its own actions? Also, if one slowly began to dismantle this intelligence piece by piece, at what point will it cease to be conscious? Finally, what even is consciousness? If consciousness is the ability to be aware of one's surroundings, then what's stopping a rock from being conscious? It interacts with its environment through gravity, and if you isolate the rock in space and bring some other mass closer to it, won't it interact with the mass by being attracted to it? Finally, how do we know that we aren't AI? That we aren't simply part of some large algorithm trying to maximize our own well-being? Well, whatever the nature of reality may be, if the study of artificial intelligence has taught us anything, it's that if you want to get better at something, follow an iterative process, work smarter instead of harder, and be aware of your own biases. Thanks for watching, and I'll leave you with a short clip of Google's DeepMind algorithm learning to walk through obstacles.